Hey, my name is Afonso Rosa. I'm an iOS engineer at Farfetch, and welcome to another Farfetch Mobcast, series of videos where I'll share our findings with the mobile community.
Hello, I'm Che, and I'm also an engineer at Farfetch. In this episode, we'll talk about tracking with different approaches and how we have implemented a solution to track the Farfetch iOS app.
Analytics is a cornerstone of all successful mobile applications. However, it is normally an afterthought. More often than not, it is forgotten until someone asks questions about how the app is performing or how our users are behaving. But you might be wondering, why is it so important? Thierry, want to give your thoughts about this?
Well, imagine that we own a gold mine. So we have a system of workers breaking rocks all day trying to find gold. But what happens when one of them finds it? Does the miner just keep trying for more gold? Or does he communicate to us the system where he found it? Then, based on his information and also from the other miners, we can map where the gold is concentrated and focus our efforts, our resources on the best region. You see, track some events and based on them, we took the best possible action. The same principle can apply to a variety of situations, include our focus that should track a mobile application. However, our goal here is to understand how users behave or use our system, which apps they perform more, how they reach a specific feature, and how it was really used. Or if not used at all, we want to know that too. With that in mind, tracking is the best tool for collecting all this information to develop better features, detect eventual problems, and focus on what really matters for our customers.
I don't know. I find it a bit boring. I see why it's important, but it seems complex. You don't have a visual feedback of what you're doing, sometimes it breaks without anyone noticing, and it can pollute your code. Moreover, it's quite difficult to start or to properly implement, and to manage it. Is it really worth all this effort?
Take it easy, Afonso. It's not that difficult if you choose a good strategy. We have some different approaches, different pros and cons. For example, there are some simpler, straightforward implementations. Just create a single class which holds everything. Let's take a look in practice how this could work. I have this action of adding a project to the back, and we are going to track it. One of the most common approaches is to have a singleton to access this class. So, for this purpose, create a tracking class, an instance to use in all the app, and inside the tracking call, inside the logic of adding to the bag. It works fine, but this doesn't look so good. We all know that singleton is not the more recommended design pattern. For us to avoid this singleton trap, we can use a static class to hold our tracking, and still API accessible, like this. Both approaches are very easy to set up. A new developer in this code base can quickly understand this pattern, and it's simple to use across the app. Despite this, not all that shines is gold. By using these strategies, we end up polluting our logic code, because we have the tracking class in our classes. Plus, everything will be held in a big tracking class. It can grow exponentially, and it's hard to keep state of any information.
That seems pretty cool, Thierry. However, how can we divide all of this code? Well, we can have a tracking class per screen where all the analytics logic is. To do this, we can use a static approach with separated classes. There are also some other patterns we can try. We have the observer pattern. It's quite similar to the static approach, having the same advantages, but with a different communication type. Furthermore, we can use delegates, the most used iOS design pattern, which is always a simple approach. As you can see, this doesn't add much more boilerplate than a singleton or static class examples. Moreover, as we have a designer/class per screen, they can be more personalized and easier to read. Another big advantage of these approaches is that you can keep state in the tracking classes. These two strategies do shine a bit more, but still aren't gold. View controllers still have tracking-related code, which doesn't allow us to parallel work as well as we wanted. In small projects, this might not be a problem. However, what about big projects with many developers.
Exactly. Big projects make more attention to organization and conflicts with many people working on the same code base simultaneously. Huge projects can have logic flows that are hard to understand, and sometimes the responsibilities of the classes are mixed together. Therefore, if you have tracking code in other classes, parallelizable work is more complex and not so beautiful. Based on that, you need to find your goal, an approach capable of not polluting your logic code, permitting parallelizable work, and with a good organization structure.
Theory! I just remember something else. AOP, as in Aspect-Oriented Programming, which is a programming pattern that aims at increasing modularity by separating different responsibilities into different classes. Basically, the main purpose of this paradigm is to connect aspects, actions of the app, with tracking handlers, or logic controllers for tracking, without including code anywhere else but these handlers. How do we do this? There is a methodology in AOP called hooks. This is similar to observers, but the main difference is that they connect with specific methods at runtime without needing to be called in the original functions. From that moment on, we have two separated classes with different responsibilities, without polluting code with tracking, and easy to parallelize.
Now, bring to our context, to the Farfetch project, a huge code base with over 5 years of development, more than 50 iOS engineers, and new features being included every day. As you can imagine, this can lead to a lot of challenges, such as conflicts, high maintenance, and slow implementations. So, we need something closer to a good solution, and we find this by implementing the AOP alternative, which allowed us to mitigate this kind of problems.
Picking up the torch, let me explain how we used AOP. In order to keep our code clean, we created the tracking handlers, which we used to store all the code needed to connect the events with the tracking coordinators. Furthermore, we also have auxiliary extracts that help us process the data each provider requires, without replicating the logic every time. This is a simple overview of our approach. Now, let's dive into the specifics. Theory.
Diving in, let's begin with hooks. Basically, they are blocks of code that are hooked to the methods, which give us information in order to track a specific screen or action. This way, any extra processing, setup, or data sending is performed elsewhere, and it doesn't pollute your business code. However, not all methods can be hooked directly. For those, we use an extra layer of swizzling. For more detailed information, please check out our blog post, Simplifying Mobile Analytics Tracking at Scale, in the description.
Oof, this seems complex, which brings a question, where to place all of this? As I mentioned before, we have these classes called tracking handlers, which have a one-to-one relationship to a given screen. Besides this, we have temporary structs called raw infos. They are used to keep state of the different tracking needs, like which views have the user seen. These handlers are auxiliary structs to keep our code tracking free. All the extra processing we need for the different providers is done in the tracking coordinators. Coordinators are also classes with a one-to-one relationship to a screen. They pick up whatever tracking handler sends them, quite often the raw info, process it, and send it to the analytics provider.
One more thing, now that you have the coordinator and the handler built, we use delegates to create a communication between them. The tracking coordinator implements the events called from the hooks of the tracking handler, and inside them we can process the raw info and send it to the chosen provider dispatcher. Each provider adds the specific generic properties for each tracker and sends the events which will be analyzed by the data team.
The theory sounds pretty cool, but it is a bit hard to follow and understand. We notice this especially when we are onboarding new members and we required boilerplate when we needed to track a new screen. Furthermore, the setup is a bit complex as you either need an external library or to create an internal one to process the AOP. However, we did come up with some aids and improvements to help us make this process more agile. Theory, want to show us?
Of course! So, with all this theory in mind, we are going to show how it's really implemented. Let's open a generics code project. Here we have a function add to bag, and you are going to track it. First, let's build our delegate so you can manage better the events that you want to track. In this case, we are tracking every time the user adds something to the bag. Now, we create our handler with the delegate that you created previously. We pass the delegate on the initialization of the class. Inside the execute rooks, we link our events to our tracking. We build a block with the signature of the action and decide we call the respective delegate. To really execute the rooks, we do this inside a do catch. We try to hook, passing the select signature of the edge to bag action using the previous created block. We are not dealing with any errors here, so let's just write an assertor failure with a generic message. Before we move on, we call the method execute rooks on the init. To finish our tracking structure, we create a tracking coordinator that has a dispatcher that will send all events to an analytics provider. Now, the most important part. It implements the delegate and dispatch when the event happens. However, for all this to work, we need to link our tracking to the app. For our demonstration purpose, we create directly on the app delegate. But you can also create a manager for this. Now, let's run our app. So we click on the add to back, and the event is tracked.
Awesome theory. However, I think there's room for improvement. Let's start with the raw info. This will hold some state information. It has a parent protocol, so it can be used generically in the base tracking handler and tracking delegate protocol. Having the raw info created, it's time for the delegate. This delegate will look almost the same as Thierry's. However, its parent already has a didenter and didexit methods, which will allow us to track how long the user stayed on the screen. So new delegates will only need to create the specific actions for each screen, like the did_add_to_bag here. Now the tracking handler. This new tracking handler also just needs to specify its particular actions. However, thanks to the base tracking handler, it gets a lot of features for free, like the raw info, application state observer, lifecycle method hooks, and more. Most of that is the same for every screen, therefore we placed it in the base tracking handler. The new version of the tracking coordinator will have more boilerplate. However, this one is far more powerful. It has a few required properties, like the time tracker and unique view ID. Moreover, the tracking page coordinator protocol has a default implementation of the did_enter screen, which will set up the mentioned properties and start the time tracker. Finally, it has a connection to the did_exit methods of the delegate. For the purpose of this demonstration, they will both do the same. The final part is here in the app delegate. It's quite similar to Thierry's, the difference being the tracking handler requires that we specify its delegate type, in this case the improved tracking coordinator. Now let's see this in action. First, we open the console so you can see the data sent to the provider. Then tapping the Add to Bag button sends the unique view ID of the screen and when the action occurs. When going to the background, we trigger the did_exit and dispatch the page event, which includes the same unique view ID as the action, how many times the user tapped in the button, and how long the user spent on the screen.
You see, not that hard. We did implement a complex structure, however we were able to tackle other problems. For instance, with the use of the pacing tracking handler and protocols, we were able to reduce our boilerplate and simplify the onboarding and setup. Moreover, or capable of not imploding your logic business code, permitting parallelizable work and with a good organization structure. Consider the pros and cons. The benefits-risk ratio is clearly on the benefits side. Of course, you can choose other options to implement tracking, but the important thing is to implement a good solution that fits your mobile application.
You are right, Thierry, and even more important is that independent of your approach, tracking is essential to any system. The collected information is one of the best guides to make a good and calculated decision, from extracting gold on the correct places to creating a new feature for your users.
So, what are you waiting for? Just track it.
That's the spirit. We hope that you found this video useful and stay tuned for more episodes about tracking and other subjects on Farfetch Mobcast. See ya!
Bye!